Hey everyone, I'm Natasha and welcome back. So today we'll be doing a new topic, and that is resolution of a vector, okay? And so actually this topic is in the chapter number 4, motion in a plane. And so actually I forget to do that topic when our analytical method of vector addition topic is going on. But don't worry, today I'm with this topic, and so let's start today's video without wasting our time. Okay, so let's get started. So in today's video we are going to discuss about resolution of a vector. Okay, yeah, got it? Okay, so first of all, a question is coming that what is the resolution of vector? Okay, let us see through a figure, or I can say let us see through a example. Okay, yeah. So first of all, let me tell you that what is a vector, and I hope you already know that what is a vector. And so let me tell you once again. So vector is a line having magnitude and direction. Okay, vector is a line that has magnitude and direction. Yeah. So vector is a line having magnitude and direction. Vector is a line having magnitude and direction. Got it? Yeah. So now let me just draw the figure through which I'm going to tell you that what is a resolution of vector. Okay? Yeah. So here it is our x-axis. Here is our y-axis. Okay? X-axis and y-axis. Okay? These are perpendicular axes. Got it? And suppose there is a vector, or I can say resultant. This is a resultant. There's a resultant in between x-axis and y-axis. Got it? Is it okay or not? I think so that it's totally fine with you, with all of you. Yeah. So let us say that this is vector v. Okay. This means that our resultant is v. Vector v. Okay. It can be velocity. You all know that what is the symbol of velocity, and it is like this. But this is not our that velocity or that v vector. It is a simple vector v. Okay. It is simple vector v, not in velocity. So just like vector a. Vector doesn't mean anything. Actually it is, and it is acceleration. Okay. It is acceleration, but never mind. Let us just continue. Yeah, so there's a resultant v. Got it? And so here's our theta. Here's our theta to the horizontal. Okay? This will be a vertical, this will be a horizontal. Yeah, so this is our theta. Got it? Yeah, so now, wait, let me tell you that in triangle ABC, what? Let me tell you. Wait. Okay. So let me just make a perpendicular line. Okay. So here it is. Now, as you can see that this is now 90 degree. Okay. So, and let me just say that I'm making a parallelogram. So let me just first of all complete the parallelogram. Okay. Yes, it's done. Now let me just name these points. Okay. Let us say this is B. Let us say this is A, and this is B. This is C, and this is D. Okay. This one is A, B, C, D. Okay. Yeah. So now what we're going to do? Simple. We're nothing going to do. We're only going to see that if we have to find the component of vector v, this one. If we have to find the component of our resultant, then how we can find it? How we can find its resultant? Sorry, how we can find its component? components. So let me tell you that you simply have to find the x component and y component, okay? So first of all, for finding the x component, what we're going to do? So let us say that in triangle ABC, here it is triangle ABC. I make a perpendicular line, so this is how, this is mainly triangle ABC, okay? So what we're going to do is that for finding the x component, we're going to use the formula, okay? Yeah, so simply as you can see that if you know theta is along x-axis, then cos theta will be used, okay? So here cos theta, but here theta is not, theta is not along y-axis, it is along x-axis. So I'm going to use cos theta in x-axis, but I'm going to use sine theta in y-axis, okay? Yeah, so now along theta, so of course cos theta. So what will be our cos theta? What will be our cos theta? Let us see. What will be our cos theta? Yeah, so now, so first of all, the formula for finding the cos theta is our base upon hypotenuse, okay? Base upon hypotenuse. So what is our base? Let us see in only this triangle, okay? Only in this triangle. Yeah, so you can see that AB is our base and of course B is our hypotenuse, okay? Means resultant is our hypotenuse, and you all know that hypotenuse is the longest side of the triangle, okay? Yeah, so our base is AB and our hypotenuse is V, okay? Yeah, so now we're going to do what? I'm going to write that AB is equals to V cos theta, okay? V cos theta. But how? As you all can see that I've shifted, I put the AB on the left hand side and cos theta on the right hand side. So that's why, and V as it is, V as it is on its place, okay? So this is how my AB is coming V cos theta. V cos theta, okay? So I can say that the x component is V cos theta. V cos theta, okay? So this is, so now we have find out our first component of V, our vector V. Now we're going to see the second component, okay? So actually we were talking about triangle ABC. So, as you all can see that, wait, let me just ask you a question, okay? The question is that, is AD is equals to BC? Is AD is equals to BC? Think? Yes, of course. Means, if we're getting the value 5, means, suppose BC is equals to 5, then AD will also be equal to 5, but how? What is the main reason behind it, okay? So let me tell you that these are parallel. As you all can see that these are parallel to each other. That's why I'm not gonna use AD. We're only talking about triangle ABC, so I'm gonna use BC except AD, okay? So now we're going to see BC1. Okay, so for BC means as the same for AD, we're going to use sine theta, not cos theta, okay? Sine theta. And so sine theta is equals to what? So sine theta is equals to perpendicular upon hypotenuse. Means perpendicular height upon hypotenuse. Got it? Yeah. So what is our perpendicular height? It is BC, and so I'm going to write BC here, and our hypotenuse means our resultant is V. Got it? Now as it is same like this one, this method, I'm going to say that BC is equals to V sine theta. V sine theta, okay? V sine theta, okay? Yeah, so this means that AD is equals to BC. Same as it is, AD is equals to BC, so I can say that AD AD is equals to V sine theta. V sine theta, okay? I forget to make the arrows. So this is it. V cos theta and V sine theta. Got it? So we find out all the components of vector V. X component done, Y component done, and I can also say X component as horizontal component and X axis as X component as horizontal component and Y component as vertical component, okay? According to their directions, mean this is horizontal and this is vertical, so I'm going to say X component as horizontal component and Y axis as vertical component, okay? Yeah, so now we're going to continue and so I hope you all have understood that. So this method is known as resolution of vector, okay? So simply we are doing resolution of a vector, as you can see. Yeah, so now we're going to take some questions, so be ready for some questions. Yeah, so now our first question number 1 is find the X and Y components. Find the X and Y components of given figure. Or let me just write of vector shown. Okay. So for now I'm going to write the question like this way, okay? So let us try to write the question in short, okay? So that's why I will use that. Find the X and Y components of vector shown. Vector as shown can also be, right. It will also be right, vector as shown, okay? But I'm going to use vector shown. Got it? Okay, so there are actually 2 parts in this question, okay? So first of all, let me just draw those figures that are given to us, okay? Okay, so let me say that F is equals to 10 Newton and yeah, this is it, okay? This is the first part. Got it? Okay, so now let us draw our second one part, okay? Zoop, 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 zoop. X-axis, Y-axis, and actually here there's another vector on Y-axis, okay? On Y-axis, it is pointing completely towards Y-axis, okay? And so this is vector V, or I can say velocity. So our velocity is 5 meters per second, and our force, and in our first part is force is equal to 10 Newton. Got it? So we have to find the X and Y components of these figures, okay? Yeah. So now I'm going to solve these 2 parts, okay? So let us just solve this question, and then we will move to our second question, okay? Yeah, so let me just draw this figure once again, yeah, I have to draw once again. So our solution It's really getting really bad. .30° force is 10 Newton. And C, is it okay with you or not? So I hope this will be clear to you. So now let us just continue. So I'm gonna make a, I'm gonna complete the parallelogram, or let me say perpendicular lines. Yeah. So now, as you all can see that our theta is of 30°, okay, and it is, it is a long x-axis. So remember that in x-axis means in fx we are going to use cos theta, but in fy we are going to use sin theta, okay. What does fx mean? Fx means f in the direction of x, and same as this like fy. Sorry, same as this. Fy means f in the direction of y, okay, y-axis. Yeah. So now, first of all, let me just find the x component, okay. So first of all, fx. So fx is equals to what? It will be f and cos theta. So I'm not gonna write theta. I'm simply gonna write its value, cos 30°, okay. So now cos 30° is equals to what? Do you know or not? Okay, so let me tell you that cos 30° is equals to root 3 by 2, okay. So I'm gonna write, what is the value of f? It is 10. So 10 into under root 3 by 2, okay. 10 into root 3 by 2, okay. Got it? 10 into under root 3 by 2. 3 upon 2, okay. Yeah. So now I'm going to cancel 2 and 10. So I'm going to get, what will I get? So I'm going to get 5. Okay. Is it right? Yes. So I'm going to get 5. Now let me just tell you that what will be our x component. So our x component will be 5 root 3, okay? 5 root 3 Newton. How? So multiplying 5 and root 3, I'm going to get 5 root 3 and units will stay as this same. So 5 root 3 Newton. Got it? So we find out our fx. So what is our fx? It is 5 root 3 Newton. Got it? Now let us just find our y component, or I can say vertical component. Okay, so I'm gonna write here. So fy is equals to what? So it will be f sine 30°. Okay, sine 30°. As I've told you, y sine and y sine here, y here sine and y here cos. Okay, yeah. So now sine 30 degrees equals to half 1 upon 2, okay, and f 10. So 10 into 1 by 2, cancel 2 from 10. I'm gonna get, so my final answer will be 5 Newton. Okay, so this means that my x component, my vertical component, is 5 Newton. Got it? Okay, so we've done our first one, first part. Now I'm gonna do the second one part. Actually, second part is a little bit, different from the first part. Okay, let us see what is the difference in this part. Okay, so now as you can see that we're not having any vector that is, in this direction. Okay, it is completely, moving. Or, I can say that it is completely pointing in y-axis, okay, towards y direction. So this means that And sorry, actually here our theta is of 90 degree, as you all can see through this sign. Okay, so first of all we have to find the x component. So I'm going to say that our Vx means v in the direction of x will be what? Okay, so it will be, so it will be Vx. So Vx is equals to what? So I'm going to use v cos theta, okay? v cos and so our theta is of 90 degree. See it again? Hope you all can see it. Yeah. So as you can see that our 90 degree means our theta is along x-axis. So I'm going to use cos in x1, okay? In x1, okay? Yeah. So v cos 90. So first of all, let me tell you that cos 90 degrees equals to 0. Cos 90 degrees equals to 0. So I'm going to get that my final OMG, okay? Oh my gosh. Our x component is 0. Really? Okay, let us just do our y component because our x component is 0. So no need to write here, okay? So now vy, okay? Yeah. So vy is equals to what? So here v sine theta. And our theta is of 90 degree. So v sine 90 degrees equals to 1. Sine 90 degrees equals to 1. But in this condition, I'm going to use v. Sorry, actually, you all know that when we just multiply any number from 0, then we are going to get 0. So I just, didn't write 5 here, okay? But I'm going to write 5 here. So 5 into 1 will be 5. So 5 meter per second, okay? 5 meter per second. Yeah. So our, y component is 5 meter per second, but our x component is 0 meter per second. Okay. So now, actually, I have to tell you that there's one more thing. You can know that without solving that, what will be x component. Suppose you can see that there's another vector pointing, it's completely pointing towards y direction. So this means that it's on its another perpendicular line, I can say that x-axis. On x-axis, our x component will totally be 0. Why? Because that another vector is not pointing in x-axis or any other direction. It is completely, pointing towards y direction. So our x component will be 0, and as it is, if any vector is pointing, completely in x-axis, so same, our y component will be 0, okay? Okay, got it? So we have done our question number 1. So now let us do our question number 2. So I'm gonna write, where I should write? Okay, so I'm gonna write question number 2 here, okay? Question number, wait, let me just make some space for our question number 2. Yeah, I'm gonna write question number 2 here, okay? So what is our question number 2? Let us see. An airplane takes off. An airplane takes off at an angle of 60 degree to the horizontal means towards x-axis. Okay, so it will be like same as it is like this. Okay, horizontal. If the velocity of the plane is 200 kilometer per hour, 200 kilometer per hour. Calculate its, x component, x and y component. Okay, but in the question it is written like another way. What it is? Component of its velocity. Okay, of its velocity. Yeah, so there is a question actually in the question it is written like another way, and it is calculate its vertical and horizontal component of its velocity. Calculate its horizontal, or I can say, horizontal and vertical component of its velocity. Got it? Yeah. So no need to worry. It is simply saying that we have to find x and y components, same as it is like this question. Okay. So let us solve it. Let's get started. Yeah. So let me just first of all draw the figure, because the figure you will it will be more easy to for you to solve the question, without wasting wasting so much time in that question. Okay, so I'm gonna draw the figure. Yeah, actually it will be a little bit small than this one, but it will be visible to you. Okay, don't worry. Yeah, so this is y-axis, this is x-axis, y-axis, and this is x-axis, and it is saying that 60-degree angle means our theta is of 60 degree, and it is to the horizontal. It can be to the vertical, so this means that our theta is here. Okay, our theta is here, not here. Okay, but it is not in y-axis, it is in x-axis, so I'm gonna write 60 degree here. Okay, it's so hot here. Okay, that doesn't matter. Yeah, so now it is saying that there's a velocity here. If an airplane is going to the angle, an airplane is going at an angle of 60 degree to the horizontal. So, and its velocity is given to us. So, what is its velocity? It is 200 kilometer per hour. Okay, 200 kilometer per hour. That is taking too much space. I'm not gonna rub. What it is? Wait, please. Yeah. So it is 200 kilometer per hour. Okay. So velocity is equals to 200 kilometer per hour, and so we have to find the x and y component. So what we're going to do is, let me just make the perpendicular line. It's not straight, I know. Let me make it straight. Now this will be like this, okay? And so now I'm gonna simply calculate its x component first. So this means Vx, okay? So what will be our Vx in this question? Yeah, so our Vx will be what? So as you know that, our theta is pointing, our theta is along x-axis, so I'm going to use cos here. So V cos theta. So what is our theta? Theta is of 60 degree. Oh, come on. Yeah, so our theta is of 60 degree, okay? And so now, what is the value of V? It is 200. And the cos 60 degrees equals to what? Do you know? So cos 60 degrees equals to half, okay? 1 by 2, okay? 1 by 2. Do you know that what is cos 60 degrees equals to? So cos 60 degrees equals to 1 by 2, as I told you, okay? So 200 into 1 by 2 will be, or I can say half. So I'm going to cancel 2 and 200. I'm going to get 100. So our Vx means V in the direction of x, or let me say x component. So our x component is 100 kilometer per hour. 100 kilometer per hour, okay? And I can say that this is our horizontal component. Okay? Horizontal component. Yeah. And so now we have to find the vertical component. So let me just write here. So what will be our vertical component? Let us see by solving it and by finding the r y components. Okay. So now I'm going to use Vy. So what will be our Vy? So our Vy will be, so our Vy will be what? So it will be V sine theta because cos is here. So of course here sine will come, okay? V sine 60 degree. And so now, what is the value of V? 200 kilometer per hour. But I'm not going to, write its unit. I'm only going to write its, let me say magnitude, 200. Yeah. So sine 60 degree, but sine 60 degree is equals to root 3 and root 3 by 2, okay? 200 into root 3 by 2. I'm going to cancel same as this. I'm going to get 100. And so, but our Vy means our vertical component is 100 root 3 kilometer per hour. Wait. So wait guys, I think so that you can't see the question. So let me just, make some space. Takes off to the velocity. If the velocity of the plane, calculate its x and y component of its velocity. Yeah. So now I think so that you can, see the question. Yeah. So now what it is? So our Vy will be 100 root 3 kilometer per hour. Got it? Wait, let me just check my camera. Is it coming in this given space or not? Means you can see it or not. So I hope you can see it. Yeah. So it's clear. It's clear to all of you. So this means that our vertical and horizontal component is, so first of all, vertical component it is 100 root 3 and our horizontal component is 100. Same units will stay as it is same. Kilometer per hour, and here also kilometer per hour. Yeah. So actually that's all for today, and I hope you all have understood all the these two questions and our main topic. So thanks for watching, and so we're now going to there are still some topics left in our chapter number 4, motion in a plane, and it is like sine law, cosine law. Yeah, that's it. Yeah, and so whenever we will complete our chapter number 4, then Obviously, we will be continuing our chapter number 3, motion in a straight line. Okay. So once again, thanks for watching and have a great day.